Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
Wait for some time to make it happen. Okay, this is called as a root guard feature. Now we will see the port fast feature and Bpdu guard and Bpdu filter. Now Bpdu filter is not available in simulator. In real life it is available. Okay, and then we are interested to go for another version of spanning tree protocol is called as rapid spanning tree protocol. This is the one which is currently available in all the switches. It is a rapid spanning tree protocol, because it is switchover is very fast. Now I am once again coming back to the normal. Now what is a port fast and why we want to use it? Okay, now let's take an example of this computer. Correct. If I connect a server, if it is an end computer, that's fine. For example, I connect a server over here. Correct. Now this server is nothing but a database server. This is a database server, and I connected this server in my organization people to access the database. I will give the IP address 192.168.1.25. Now look at the things carefully. If I connect the wire to this computer, I will go to the switch. Okay, I will exit out of it and fire the command called as show spanning tree. You can see there is a process called as listening. Correct. Currently, this port number 4 is in listening state and it is still in the umber color at this moment of time. Correct. Now it is turning to the learning, because our STP protocol works on listening, learning, and now it will become forward. Correct. Now remember that this particular behavior, if it is connected to the normal computer, it is okay. But the point when it is connected to the server, this behavior is somewhat problematic. By mistake, for example, by mistake, while doing troubleshooting, I unplug this cable. Okay, I unplugged it. If it is connected port number 4, I unplug this cable and immediately I connected back to the port number 4. But what happened? Once again, listening, learning, 30 seconds, and then it will become a forwarding. Why? Because STP is running. STP is running on every particular port. Correct? So he is taking 30 seconds to make your traffic enable. Now 30 seconds, your server is down. Correct? Now this is the problem. This is something very good solution for your computer, like your laptop, your client computer. It is good. But in case of servers, this behavior is not good. Correct? Now here we have a solution in STP. We can disable STP protocol on this particular port number 4. We will stop him. So he will not go for listening, learning at all. He directly go to the forward. But condition apply. The port which you are using to disable the STP, and you are enabling the port fast feature. The port fast feature is nothing but you're actually practically disabling the STP running on that particular port. That is a port fast feature. But remember that the port where you are enabling this feature, it should be connected to the end devices. Remember that this is very important. Okay. For example, if I go to the port number 4 and enable that port fast feature, and after some time, I remove this computer and connected the same cable to the another switch. If I remove this server and connected another switch on this particular point, then it is problematic because your STP is disabled over here. So the looping will not be avoided. Whatever functionality which we have discussed so far, it won't happen. So looping would be happened. Correct? So remember that whenever you're using a port fast feature, you need to make sure that it should be connected to the end devices only. Correct? So let's enable this port fast feature on port number 4 on this switch. Okay, and let's see what differences actually happen. So I will go to the interface, config T interface fast Ethernet 0/4. I want to go for spanning tree port fast. Okay, this is the only command. He's giving you the warning. The warning clearly says port fast feature should be only enabled to the ports connected to the single host. Hubs, concentrators, switches, etc. to this interface. Port fast can cause temporarily breaching groups. There is a chance if you connect that particular port to these devices, there is a chances of looping. So it should be a single host. So I enable this port fast feature. Now I disconnect this cable from this and connect it back, and we will wait what happened, whether it's going for amber color or directly going for green color. You can see it's not doing listening and learning, it's directly going for forwarding. This is called as port fast feature. Correct? So once again I will show you. I will disconnect it, connect it to the port number 5. He's doing listening, learning right now. I will disconnect it and connect it to the port number 4. Immediately it's become forwarding because port fast feature is enabled over here. Correct? Is it clear? Now once again, port fast feature you are enabled, but by mistake somebody not aware of it and connected the switch to the port number 4. Connected the switch to the port number 4. He take out the cable and connect it to the 4. Now what will happen? Correct? Now this is a very difficult condition when you do this. Now here we do have 2 more security options. Security means if this particular thing has happened, it should avoid the looping immediately. Correct? Now that feature is called as Bpdu guard and Bpdu filter. Correct? Now if I disable STP over here, correct, and if I connect any end devices, I'm immediately going into the forward stage because I do have STP disabled. I'm not expecting any Bpdu traffic which is happening in STP. I'm not expecting that particular traffic coming from server. That traffic only comes from switch. Correct? So how this Bpdu guard and Bpdu filter help me in this situation? By mistake, if I connect this wire from here and connect it to this switch, correct? I'm not doing it right now, but if I do it, immediately what will happen? This switch will start sending the Bpdu traffic on this particular port. The moment the Bpdu traffic comes on that particular port, if I enable Bpdu guard, now this is root guard, it is something different. Now this is called as Bpdu guard. If I'm receiving any Bpdu traffic over this particular port, immediately I will shut down this. Immediately I shut down this because STP is disabled on that particular port. Correct? This is very important. You need to understand this. Correct? Bpdu filter. Now Bpdu guard immediately disable that particular thing on your particular router. Sorry, switch. Bpdu filter will exactly do different things. Correct? Bpdu filter automatically convert, or you can say automatically enabled STP on that particular port. Correct? Now this is something which you can use in order to avoid some accidental connections. Means accidentally somebody connect a switch over there. You are not supposed to be happen like that. That time, if you have enabled any port fast feature, you should make sure that at least Bpdu guard or Bpdu filter should be enabled on that particular port. Correct? This is very important if you are dealing with post port fast feature. Correct? So let's understand how Bpdu guard actually work and how we can configure that particular Bpdu guard. Correct? So let's go to the same port number. Now Bpdu filter, we cannot enable it. So I'm in that particular thing. I will say spanning tree Bpdu guard enable. Correct? Now we have only Bpdu guard feature enabled. Correct? We do not have Bpdu filter option, but in real life it is available in that particular thing. Correct? But here in a simulator we do not have that particular thing. Okay, now it is enabled. Now let's connect the wire from here to switch. Connect anywhere over it. You can see it's blocked. Why it is blocked? Because earlier I told you that this particular connection is a port fast feature, but you are connected to the switch. Switch is sending the Bpdu traffic and Bpdu guard is enabled on this particular port. Immediately, the moment he received the Bpdu traffic, he stops it. Correct? So this particular feature is Bpdu guard. Bpdu filter will not block anything. He will allow the traffic to go on. The only thing which he can do, he automatically convert that particular port fast feature into the normal STP enabled feature. Correct? So this is what we can call it as port fast. Correct? Now the last thing which we would like to understand is a rapid spanning tree protocol. Okay, this is the latest version of the spanning tree which we have. Now currently whatever spanning tree version which we are using, I will connect it back to the computer.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, I just need to make this interface up. Okay. No shutdown. Okay, it will become directly green. Okay. Now let's see what is a rapid spanning tree protocol. Now rapid spanning tree protocol help us that whatever switchover which you are going to do. Okay, I told you that normally if failover is happened on this particular port, now to turn on this particular line up, it required 30 seconds. If any indirect connection is failed, okay, in order to do the switchover, it required 50 seconds. This is a normal behavior of per VLAN spanning tree protocol, which is actually running on our switches. But there is one more protocol called as rapid spanning tree protocol. He will help us to do that particular switchover very fast. We will see how. Now you can see I will once again demonstrate you the switchover. Now currently all the computer, this is trying to ping this computer. I will go to this interface and I will shut down this particular port. What is this port? It is a fast Ethernet 2. I will shut down, so his connection would go. So I will enable. Now this is a normal spanning tree protocol. Okay, so config T interface fast Ethernet 0/2. I will say shutdown. Then the moment is shut down, the switchover would be happened, but till the time it will not shut down, because I should ping this machine because it is pinged over here. So this connection is going on. So let's 168, sorry, 168 dot 1 dot 150. Okay, it will not affect this switch actually. It should directly going from this switch to this switch. So what I will do, I will ping 150. Okay, now he got the alternate path. That's the reason it's pinging. Okay, I will make sure that I will turn on this particular path. I will say no shut. Okay, now you can see it is saying request time out. The traffic is waited. He's waiting. He's waiting. He's waiting. Now this is a normal behavior of spanning tree protocol. Waiting. Okay, now switchover is happening. Correct. Now what I will do, I will convert every switch. Now remember that the behavior of fast rapid spanning tree protocol, it's called as fast switching time, but it is only applicable only when if you have rapid spanning tree protocol enabled on every switch. Correct. If you enabled rapid spanning tree protocol on this switch and per VLAN spanning protocol on this switch, it doesn't work at all. Correct? It doesn't work at all in that particular case. Correct? So be careful. You have to choose rapid spanning tree protocol to every switch. So if I go to this switch, I will say exit. I will say spanning protocol mode. Okay, rapid PBST. Correct? I said rapid PBST. Okay. I change this mode over here. I will say enable spanning tree protocol mode rapid PBST. Okay. Exit spanning tree mode rapid PBST. Correct. Now everything is rapid. Now see what is the difference which you can get. Okay, wait for some time. Okay, still doing something. Okay, we are changed the entire protocol, so we will see what protocol which is currently running regarding spanning tree. Show run. So it is rapid PBST. Initially it was just a PBST, that is a per VLAN spanning tree, but we have changed it to the rapid PBST. Now see the difference. Now this is the same computer is pinging to this. Okay, now we know that now technically speaking we got 4-5 request timeout, then the switchover is happened, but technically speaking it required very less time to do the switchover in a rapid particular PBST. So what I will do, I will go to this computer. I will keep doing this. Okay, so I will shut down this path. This path should be turned on. So I will go to this interface 2 is there. So I will say interface fast Ethernet 0/2. Enter. I will say see how fast it would work. It's done. It is done. The switchover is done. Immediately this particular things becomes green immediately. I will say no shut. Done. Okay, it becomes green. Your traffic would be immediately started. So this is the benefit of rapid spanning tree protocol. There are some feature called as a backbone fast, uplink fast. Okay, this all feature was legacy. Now what they have done, they introduce all these fast features into a new protocol. So rather setting uplink fast or backbone fast manually, we need to do that in early days in order to do the switching faster. But nowadays they said you do not need to do any configuration for backbone and uplink. You can simply go for this particular type of protocol. It does have all the features. Correct? I hope you have clear what is a spanning tree protocol is. There is no doubt till so far. Any doubt in this spanning tree protocol? How spanning tree protocol works? What is the purpose of it? How the things are actually gets picture and how the switchover is happen. Then we have seen the root guard, port fast, rapid spanning tree protocol. Now there is a small thing called as primary route and secondary route, but to be honest with you, it is rarely used in certain cases that one of the root bridge has been removed, the other would be coming into the secondary would be the primary master. So it's like a primary and secondary. If primary goes, secondary will take over. So that kind of sort of implementations are there. Correct? So I think everything is clear. I hope if you have any doubts, you can ask me. No problem at all. I will re-explain everything if you want. Okay. Concept which we need to understand regarding the switching is called as ether channel. Correct. Now, first of all, understand what is ether channel and how we are going to use it. So let's delete these diagrams. We don't record anything. Correct. Now let's understand what is the ether channel technique and when we are going to use it. Ether channel. Okay. Now look at the scenario where I do have something like this. I do have, this is my main router. You can say this is my core router. This is my distribution router. And I do have multiple routers over here, which I connected to the different departments. Maybe I do have many more router in front of that. This is a access layer router. Now all the routers are actually connected in this way. So all the branches are city branches are connected to, these are the branches in the city. This is the city headquarters and this is my headquarters. So all the data traffic which is coming from all these branches is actually, okay, maybe I do have computers over here, maybe I do have a small switch over here, hubs over here, and above that I do have multiple computers connected, depends on the environment. But look at the situation. You can imagine how many data is transferring from all these computers, which is here. Correct? I do have a huge network available in this side. Correct? Now all the data are generated, all the data would be transferred to these switches. Okay? All the data are gathered from various sources from this switch and it would be transferred to my main switch. Now through this I may be going to the router and router is going to the internet, that I don't know. My concern is these backbone switches, okay, who is actually collecting all the traffic and collaborating all the traffic and transfer from one to another destination. Correct? So I concern about this link. Okay. Now why I should concern about it? The concern is very simple. What is the speed or bandwidth or how much traffic which I can flow from this single line? You can see how much traffic is generated by these switches and they are collectively coming to this switch. This switch is doing collaboration of that particular traffic and transferring that entire traffic to this backend or core switch. Correct? Now this is a problematic. Correct? Here I am actually having a single 100 Mbps line or maximum 1000 Mbps line connected over here. You can see how much data are generated and how much 1 Gbps line, for example, but currently it is 100 Mbps. You can see the data which is generating from my offices. I want to collect that particular data. I'm collecting that particular data and sending it from one switch to another switch by doing the collaboration. It's good, but the bandwidth which you are using between these two backbone switches, it would not be enough. So what is the solution which I have? The solution which I can have, I can connect multiple wires between these two switches and I will make sure that the bandwidth and throughput which we are using would be available over here. Correct? So this is what we can do it.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay. Okay, so what we can do, let's connect the wire. But what is the problem? If I connect two wire, what is my throughput? Let's say 200 Mbps or 2 Gbps, correct? But what is the problem if I connect the wire over here like this? The problem would be STP will do his job, correct? STP will block this line, correct? But I want to increase the throughput which I'm getting on this switch, and I want to transfer this particular data. The throughput requirement is very, very huge. So rather I can combine this physical port into a logical single port. What I'm planning to do, I'm connected the wire into two ports. Now I am connecting to the two ports. You can connect it to the any number of ports which you require. Correct. So what I want to do with the help of ether channel technique, these are two physically separate ports are there. Correct. I want to configure those two ports as a single logical port. As a single logical port on this side and this side. Then what will happen? This will be act like a single line whose capacity would be 200 Mbps. Correct? It is more. The throughput would be completely different. If I connect one more line and combine this third line, it's logically one line. Correct? The throughput, the data transfer between this switch and this switch would be 300 Mbps. Correct? So this technique of logically grouping the physical adapters or logically grouping the physical interface of the switch into a one logical interface in order to increase the throughput, we can call it as ether channeling. What we can call it as ether channeling. Okay, now if I normally connect these two lines together, by default STP will do his job and STP will ultimately blocks the connection. Correct? Remember that there are two different protocols who actually do this logical grouping of these ports on the switch. Correct? The first protocol would be called as LACP. Correct? That is nothing but link aggregation control protocol. Now this is a open source protocol which we can say. Okay. The second protocol is called as PAGP. This is nothing but port aggregation protocol. Now, this is a Cisco proprietary. The owner of this particular product or protocol is Cisco. Correct? So these are the two protocols help us to build the ether channeling. That means logical grouping of switch interface as a single interface, and the purpose is to increase the throughput of your data transfer across the backbone switches. Now we will see one by one what is the behavior of this particular protocol and how we can configure that particular protocol. Now if I talk about LACP, okay, Now LACP, there are three different mode are available. The first mode is called as on mode. Second mode is called as active mode, and second mode is called as passive mode. These are the three modes are available in your LACP. In PHGP, we do have three mode. One is called as on mode. Second one is called as desirable mode. And third one is called as auto. Correct? Now understand what this mode are and what is the purpose of it. Correct? You can say these mode are playing a very important role in order to create the link aggregation. Now if I see my mode, let's talk about LACP first. Now this is a protocol to link these things together. Let's see, this is my switch 1 and this is my switch 2. Correct? Now I come to this switch and say this is my interface 1 and interface 2. I have configured this interface and say you are on the on mode. Okay, you are on mode. And other side, if I say you are also on mode, that means if I go to this switch, go to these two interfaces, group them together and say you are on, then I will go to another switch, combine these two lines together and configure on. If both the side are on, then my ether channeling would be created over here. Means I am able to successfully create grouping of that particular channels. Correct? If I say this is active, one side is active and second side is either is active or either it is a passive. I don't know. So one side is active, either is it's active or say active passive. Correct? Then you will able to create the ether channel, means ether channel would be successful. Correct? Another case would be if I have a passive over here, active over here, it would also get connected, no problem. Here I have a on, here I have a active, that is also possible. You can see both the side I'm talking. If I say on, my ether channel would be created, active ether channel would be created, active passive ether channel would be created, passive active ether channel would be created, on active ether channel would be created. But if I say passive, my ether channel would not be created at all. So there are two cases where ether channel is unsuccessful. One, if I have a passive option. Correct? Second, I have passive, active or any option selected over here and I do not have any configuration over here. My ether channel would not be possible in LACP. So it is a configuration option. I will go to these two interfaces. I say this is an active, this is a passive. Ether channel would be created. I said this is a on, this is an active. Ether channel would be created. Correct? So any given point of time, I need to make sure that one side of this line should be active, means they should be ready to create Ethernet channeling. Now same case for our port aggregation protocol. If I have on, I should be able to see that the ether channel would be created. If I say desirable, correct? Desirable on this side, desirable on this side, my ether channel would be created. Correct? Desirable on this side, auto on this side, still I am able to do that. Correct? I have on desirable over here. I do not have any configuration over here. I'm not possible. Correct. I have on over here, desirable over here. Correct. Remember what I'm saying. Then connection is not possible. Correct. Auto, not possible. Auto, not possible at all. So look at the combination carefully for these two type of protocol. If I talk about LSCP, if I say on, ether channel would be successful. If I say active, ether channel would be successful. If I say active, passive, ether channel would be successful. If I say passive, ether channel would not be successful. Correct. So majority of cases, if I talked about LSCP, I will majorly use active or active on both the side. That means both the side are ready to create ether channeling. In case of PAGP, I will prefer to use desirable and desirable on both the side. So both are ready to go for link aggregation. Correct. So these are different type of protocol which we can use it. Correct. Now I will show you one example how we can do this. Correct. Now okay, so if I want to use these two port, I will say this is a port number, let's say connected to the gigabyte. I say gigabyte 1, this should be gigabyte 2, this should be gigabyte 2. Okay? Gigabyte 1, 2. Now here is the problem. Okay, this wire is going to gigabyte 2, gigabyte 1. We don't want that. Okay, we want similar to avoid the confusion, otherwise it's a problem. Okay, I will take a wire, I will connect it first. I will take this wire, connect it to the gigabyte interface 1. Here also it should be gigabyte interface 1. I will take another wire. Okay, this is 1. This is 5. So I will take this wire, gigabyte 2. This would be gigabyte 2 to avoid the confusion. So I know that gigabyte from this particular switch and gigabyte from this particular switch, we want to combine together with LSCP protocol. Okay, we will see how LSCP protocol actually going to work. Okay, let's see. STP will do his job, so I will know that. I will go to the range command. I will say enable. I will say connectivity interface gigabyte 0/1. Okay, so range command is necessary over here because you are going to set anything over here. Now under this range there is an option called as channel where is that option? Is there option? If I say channel protocol, okay, it will be, there are two different protocol. Now remember that if you have selected only one protocol to use, you have to use only one protocol. Otherwise, you can say one side you are configured with LACP, other side you are configured with PAGP. It is not possible. So if you have using one protocol, you have to use one protocol over there. Now here we want to go for LACP, correct? LACP. Now LACP, what is the idea? If I'm saying active, one either side, either it has to be active, other side has to be passive, but we will make sure that both the sides should be active, correct? Then I will say channel hyphen group. I will give the group name or number as 1, and I will say mode of this group would be active. Okay, that is done. Now what he is actually doing, he's creating one more Ethernet port by the name of port channel 1, and he's logically combining all the port which we have selected into that. So if I say exit.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
So Ether channel. So there is a group which is already configured over here. No problem. Now let's go to other side. Let's go to this side. This is also the same. We will go for enable conf t interface range gigabyte 0/1 to 2. Okay, we will say now what we need to configure. We need to configure same LACP. Remember that, otherwise it would be problematic. Channel hyphen protocol is LACP, correct? Channel hyphen group would be 1. Mode would be active. I have to choose active, passive. It will work, but majorly for a safer side, majority of the people will always go for active. That's fine. Press enter. Now let's see what happened. Now I should see this is a single device. Okay, I will show you. Show IP interface brief. You will get show IP interface brief. Okay, it's not up yet. Okay, that's great. So you can see right now the Ether channeling has been actually configured, correct? So you have to make sure that you are going to go for the port number or channel number, your port channel. So you can see, go to this switch. Interface port channel. Okay, what is the number we are giving? 1. Correct? Now I would like to configure this particular interface as a trunk port, otherwise that would not happen. Switch port mode trunk. correct? So if I say exit show IP interface brief, correct? You can see this is actually the fast Ethernet which we are using, but we configured a logical device called as port channel, and that number 1. Now if I can see, I would be able to see both are green now because my data traffic is happening. It's going through both the wires which is available. Now I have done with the LACP protocol. Remember what we have done. It's very simple to understand. I would like to group these physical interface into one logical interface. The reason why I would like to do this, because the throughput which I required to transfer the data from this switch to this switch, it won't be enough. So the option would be, I would connect two different multiple wires into this switch and created one logical device, and that logical device we can call it as port channel. Now to create this logical device and do the bonding of these physical device into one logical device, there are two protocols, LACP and PAGP, correct? Now what we have done, LACP, we went to this switch, we access these two interfaces, we tell these interfaces that you are going to use LACP protocol and you are going to create channel group with number 1, and your mode would be active because that is the best option for your LACP. We will go to here. We will also do that. You are the part of group 1. You will also active. Now both the sides are active. In the case of LACP, you should have one side should be active all the time. If you have one side active all the time, he will initiate a ether channel connection on other side, and your bonding, or you can say grouping of this particular Ethernet adapter would be happened, correct? But if you keep both the side passive means he's waiting for somebody to do that particular thing for him. But if you do not have any active side, both the side are passive, nobody can initiate for ether channeling, correct? So what we have done, we told this interface that you are grouped together, you are using LACP protocol, and you are the part of one channel group, and that group number is 1, and your mode is active. Same thing we are going to do it over here, correct? Now this is the protocol of LACP. Similarly, you can do it for PAGP. Command is same. Now you have to make sure that both the side has to be either desirable, or any of the side has to be desirable, any side. So either desirable, auto desirable, anything work, but auto does not work at all. Auto means like a passive, correct? Passive. They are waiting for somebody to do the connection for him, but there is no active connection at all. Then you won't be able to make sure that ether channeling is happening, correct? Now I will show you to do the PAGP with different port numbers. Command is same. There is no difference in the command. Okay, what we can do, we will take one more switch rather disturbing this. Okay, we will take one more switch. Now we don't have any option. What I can do, I will connect it over here. We will check whether it's connected to. Okay, this is port number 6. What about this? Okay, this is connected to port number 6. What I will do, I will take. Okay, so what I will do actually, I will new switches. I will make sure that here is 1. What is this port number? 1 to 5. Okay, 2 to 6. So here I do have a 5, 6. Here I do have 1. So if I go to the command, I will go to the interface. Oh, sorry, config T. Okay, interface fast Ethernet 0. Interface range fast Ethernet 0/1 to 2. Correct. You will see channel hyphen protocol. We are going to see PHEP channel hyphen group. Correct. You will see channel group should be 2. Correct. Mode would be desirable. So I have configured the mode called as desirable on this side of the switch. Now I will go to the 5/6 interface over here. Interface range fast Ethernet 0/5 0/5-6. Right? Now I will say channel protocol should be PHEP. Right? I will say channel group should be 2. Mode should be desirable. End. Correct? So if I say, now let's see, now this is PHEP we have configured. This is LSCP we have configured. Okay. This is PHEP and this is LSCP. Both the wise it seems. I will configure active and here I configure desirable. Let's see what happens. You can see NIC bonding has been done successful. So I'm using both the lines in order to send the traffic. So my throughput Okay, sorry, my voice got disconnected, I believe so. So I was saying this is the best technique which we can use on the switches to increase the throughput. Now, when we talk about servers also, server can also have same technique where we can use the concept called as NIC bonding, or the concept which we are using called as ether channeling, where we are combined two different physical interface of the switch as one logical interface, and that logical interface I can see it over here, interface port channel number 2. I can provide all the IP address, whatever things which are required, I can make them as a trunk port. I will say switch port mode trunk. It can be also possible. So I believe that will finish our today's agenda, what we have planned. So we can say today the entire switching concept which we required to understand, it has been finished. So under the switch, you should understand what are the different type of memories are available, what are the external ports are available, what are the MAC address learning method is available, what is the port security, VLAN concept, spanning tree protocol, ether channeling, correct? Everything which is related to the switch, it is clear now, correct? Now, do you guys have any doubts regarding switching concept which you have done till so far? Any doubts in MAC address learning, port security, VLAN, spanning tree protocol, ether channeling? If you have any doubts, you can ask me. No doubts, that's great. So we will say that our switching concept has been finished. Tomorrow we will see the routing concepts, and we will try to finish the routing concept tomorrow only, because routing, it's a very basic routing which we are going to understand. Under that, we are going to understand static routing, default routing. We will be understanding the OSPF, RIP, EIGRP. These are the protocol we are going to understand tomorrow. And right now we are working on layer 2 switching. Now we are going to start working on layer 3, where two different networks which we have seen in inter-VLAN routing, but that inter-VLAN routing is within your network. Now we are going outside two different network from tomorrow, correct? So if you have any doubts, any question, please ask me. You can park your question early morning. If you have any doubts before we start the session, you can definitely ask me any question. I am here to solve your problem. Okay.
Thanks for watching. Want to study further? Join our training programs today.